Hello everyone, welcome back to my channel and I'm Neha, and in my last video I explained you how to create and deploy a smart contract on Rinkeby test network and then mint an NFT, and we also saw it how it got rendered on Opensea testnets. Now many of you have reached out to me and asked doubts, and one doubt amongst many of you was how to deploy this smart contract on Matic mainnet and mint an NFT. So yes, in this video we are going to do that. Apart from it, I have also collected some doubts from you all and I'll be discussing those doubts as well. So let's discuss about the agenda in the next section. But before that, I want to tell you, those of you who haven't watched the last video, please go and watch it, because in this video we will not be doing any code walkthrough. We'll be directly taking that code which we explained in the last video and we are just going to deploy it. So if you haven't watched it, I recommend you that you first watch it so that you get a clear understanding of what is going on in the code. Okay, we won't be actually uploading these files to IPFS and creating the metadata, so you must know how to create the metadata because we are going to use that token URI in our code in this video. Okay, so let's start the video. Now first we'll be deploying our smart contract on Polygon Matic mainnet and mint an NFT. We'll then check it out on Opensea. Now many of you had doubts that how can we deploy it on Polygon without changing a lot of code. So Matic or Polygon's chain is EVM compatible. That means whatever code we had written in Solidity for Ethereum blockchain will work as it is on Matic chain. We just need to connect to Matic network and that's it. Now we'll do a discussion on what exactly happens when we deploy our smart contract. So I think there is still a lot of gap in my explanation in last video as to what exactly happens when we deploy our smart contract. For example, we use truffle migrate command. Under the hood, truffle migrate first compiles our Solidity code and creates a directory called build/contracts, and within it stores the ABI and bytecode in the JSON file. Now understanding what ABI and bytecode is really important to interact with the contracts on Ethereum blockchain. So pay careful attention when I am explaining that. Now we'll take a closer look at what MetaMask is doing for us. We'll discuss briefly about mnemonic. For instance, recall from our last video where I told you that there are two types of account. One is an externally owned account and another one is a contract account. Now externally owned accounts are controlled by users like you and me having a private key. So yes, in Ethereum terminology, MetaMask is an externally owned account. We'll talk briefly about what a mnemonic is. Now we will revisit transaction object again and take a look at how it is determined that a particular transaction is a contract deployment. So how we verify whether this transaction is going to create a contract versus a regular transaction between two valid addresses. Now we will take a look at account object again and see where the contract code gets stored on EVM. So we'll see what all fields are available in an account object and we'll see where exactly our deployed smart contracts code gets stored on EVM. So first we'll be installing MetaMask. So let's quickly do that. I'll give you the link into the description from where you can install MetaMask. For one thing to note here is check this is offered by metamask.io, and even the number of users will give you an idea that this is the legit extension that you are installing. Extension. Okay, let's start. So we will be creating a new wallet right now. Let's create a password. Okay, next. Okay, now this is very important. You need this secret backup phrase and this is what you will be inputting in your mnemonic. So this is your mnemonic. This is 12 words which is in a human readable format. Now this mnemonic is actually used to generate your account keys as such, your private keys. So you should never share this with anyone. Okay, so you have to confirm those letters over here. Okay, let's click confirm. All done. Okay, so now we are on Ethereum mainnet. Now we need to add the network configurations for Polygon mainnet. We can actually deploy this NFT on Polygon, first Polygon testnet and then on Polygon mainnet, but it takes 24 hours for the NFT to render on Opensea. So anyway, we cannot check on the test network, and since the fees is very less, we can just go ahead and deploy directly on the Polygon mainnet. Let's copy all these details from this link. I'll give you into the description all the websites, so be sure to check out the description. Okay, now I am saving the network. Now we have Polygon network saved. Okay, now we have zero Matic here. Now we need some Matic to be able to basically pay for the transaction fees. Okay, so you can actually use some faucets like matic.supply, and there is one more faucet for Matic mainnet where you can actually get like around 0.03 Matic tokens. This one is actually seems like it is broken because I tried quite a lot of time but I could not get any Matic tokens. But yes, from here you can get, this is the official website and this actually works pretty well because I tried it and every time I was able to get some Matic tokens for my tests. So let me just take a look. Okay, let's take a look. So got 0.003 matic on the mainnet. How cool is that? Okay, but we will be needing a little more than this. So I have already transferred it into my another account, so I'll be using that account throughout this video. So this is my another account where I already have one matic token that will be sufficient for us to deploy our smart contract. Okay, so now first we will be cloning this repository, so let's do that. Okay, it's done. So I'm going to go to cdnft demo. Okay, now we are on the master branch. I have actually did some changes, and in deploy polygon I also added one script that we can directly use to mint the NFT instead of we opening truffle console and doing that one by one. Okay, so we will be checking out that branch. So we'll do git checkout deploy polygon. So I didn't wanted to mess the master branch because the other tutorial is already there, and the people who are coming from that tutorial will find it at least a little difficult to follow. So that's why I created a new branch and put all the new code inside it. Okay, now we'll be opening this folder into our editor. Okay, so as you can see, our file is now open. We have pulled this branch changes, and first we'll see truffleconfig.js. We can see that the matic network is added over here. Now what all we need to do is, first in the .env file we have to update the mnemonic that we just now created from the MetaMask account. So we have to put that mnemonic over here, and then in client URL we have to use client URL of matic network. So let's paste that here. So this is the URL that we have to use. So let's update it in the client URL. Also, let me show you the truffle config that I have added. I have added this from the official docs of Matic. So you can take a look over here. But they actually have given this RPC Mumbai Matic.today. But I believe this one, I think that is their test net. But even though if you use this other mainnet configurations like RPC mainnet.matic vigil, I actually found that I was getting this timeout connections and disconnect and other sorts of errors. So I think this is the most preferred one, and that's why they have said that this is recommended. So you also better use this one in case you are getting connection timeouts and other errors while connecting to Matic network. Cool, so we have added this. Now I'll quickly add my mnemonic, and then we can actually go ahead and deploy it on the Matic mainnet. Okay, so one more thing that we need to do is, first we need to install all the dependencies. So let's do that. npm install. Okay, so all dependencies are installed now. I'm clearing the screen, and now let's run npx truffle migrate network, and we have to use the Matic network. Now this is going to compile our Solidity code and also is going to deploy this contract on Matic. If you take a look at it, there is an initial migration. Actually what Truffle does is Truffle first deploys a migration contract, and that's how it keeps track of all our versions. So if you remember from the NFT that I was showing you on Opensea, it wrote art collectible v3. So how does it know that this is the version 3 that I deployed? So with this migrations contract, Truffle keeps track of all the changes that has been done and the deployment still where we have already deployed. If there are no changes, then they are not again deployed on the network. So that is very handy. So I think there is some issue, and our migration has failed in the middle, and this was the same issue that I was getting while the connection error. So we'll be restarting this migration, and Truffle is going to pick up where it left off. So I think the first migration was already deployed, so it is going to do the second migration, that is our contract. I'm doing this in this full screen mode. So let's use the command again. Now our second contract is getting deployed. That means our art collectible contract is getting deployed. Okay, so our deployment is done. Now this is the transaction hash and this is the contract address. So Truffle also shows you the contract address, which is really good. Now we'll be checking this out on Polygon scan. Okay, so this is our deployed smart contract. Let's check it out. See, you can see 2 minutes ago the contract was created. Let's check it. Okay, so this is our from address. If you take a look at this address 0xb8, you can see this is indeed our wallet address. This is the contract that got created. So we have actually not transferred anything. So our contract is actually not receiving anything. So the value is 0 matic. And you can see the transaction fees is around 0.003 matic, which is actually not even $0. So that is really cool. Just compare this with Ethereum fees. If you deploy the same thing to Ethereum, you might have to pay upwards of $200, $300. And if the Ethereum is congested, you just need to pay quite a lot of fees. So this is really great. So now our contract is deployed. Now we need to copy this contract address. So just copy this contract address. We'll be needing this to mint our NFT. Now let's mint our NFT. So I have written a script which we'll use today to mint our NFT. Now let me quickly show you what all is present in Mint NFT. Basically we are using Web3 library. Now Web3 library is how you interact with the Ethereum network. It takes in a provider, and provider is how it actually talks to a blockchain. So we are using here HT Wallet provider. So if you want to read more about Web3 providers, I'm going to give you the link into the description and you can read it from the official docs. Let's take a look. So the provider is how Web3 talks to the blockchain. Providers take JSON RPC request and return the response. Okay, so this is normally done by submitting the request to an HTTP or IPC socket based server. So basically this is how you are going to connect to your Ethereum node. Okay, and also we were doing all these things with Truffle console, and Truffle under the hood also uses the same library Web3. So here we are directly using Web3. Now we'll be fetching all the accounts. So one more thing that I wanted to discuss was with one mnemonic you can actually create a lot of accounts. So these all accounts will have their own separate private keys. So if you take a look at here, there are 3 accounts, but these all accounts, if you just click on create account, there will be one more account that gets created, right? But they all under the hood are using the same mnemonic. So that means with the same mnemonic you can have multiple accounts. So this is how you can use those different accounts. Maybe you have funds into your 3rd account or 4th account. So here you can use that set to send requests to whichever account you want to use. So in my case, I'm using account 0 because it is having the transaction. So this was the doubt that many people has asked, that they have stored their funds into different accounts, but when they were doing it only via Truffle, so there was no way to specify which account to use. It is by default using the 0th account. I'll tell you how exactly to unlock all the accounts. Or else one more thing that you can do is you can transfer from your other accounts to the first account. So whatever funds you have, you can just transfer it in the first account. And anyway, it is Rinkeby testnet, so not an issue. You can just play around with it. Now here, after minting the NFT, we'll be getting the balance of this account. So basically we are, till now I'm doing all the transaction from this account. This is going to give me how many NFT I already hold. That means if I have minted only one NFT, it is going to give me 1. If I minted 2, it is going to give 2. So that is a token ID also. So that's what I'll be collecting here, and then I'll be checking who is the owner of that token, basically us. So let's now start and run our program. So we'll be running this mint NFT file. Let's do that. Node scripts mint nft.js. Okay, our accounts got printed, and this is the contract address where our contract was deployed. Okay, so we have successfully minted our NFT, and let's check this out on Opensea now. So I'm on Opensea website and I'll be clicking on my collections. Then I'll be going on import an existing smart contract. Okay, live on mainnet. So this is the beauty of Polygon. We can actually do it directly on mainnet without worrying much about the fees. Now enter your ERC721 or ERC1155 contract address. So our contract is actually ERC721. This we have already discussed in the last video. So if you haven't checked out the last video, please go and check it out. ERC721 is the standard to create NFTs. Okay, now let me copy the contract address. Yes, here it is. Submit. And yep, this is our art collectible, and let's see if it is getting rendered. Yes, this is deployed on Polygon mainnet, so it is actually available for others to actually buy it. So yep, that's what about deploying it on the Polygon mainnet. Now we will be talking about some other concepts that I wanted to discuss with you all, like the ABI and the bytecode that Solidity compiler generates. So let's talk about all these concepts now. Let's now discuss what happens when we write your contract code. Okay, this is your contract source code, and this is then passed to your Solidity compiler. Now this compiler is actually going to create an ABI and byte code. Now this bytecode is what gets stored on the EVM or Ethereum network, on Ethereum virtual machine, let's say technically correctly. And this ABI is known as application binary interface. We'll take a look at it in just a bit. So application binary interface is how you talk to this bytecode on EVM. So this is the ABI that actually tells you how to encode and decode data to EVM. Now suppose this is your EVM. So this is how you know how to encode data and talk to the bytecode on EVM, and the transactions that you get out of the EVM, how do you decode it? So your application binary interface tells you the expected input and output and how exactly you should expect the schema. Okay. Now I want to talk to you about one more thing, which is how do you know that this particular transaction is actually the one which is going to create a contract. So let me now quickly draw out the transaction object for you. Okay, so this is your transaction object, and as we talked in the last video, nonce is how many transactions you have sent from this particular address, from the sender address. 2 is the recipient address. Now this is the most important field. This is actually kept empty in case if it is a contract creation. So this is empty, and when this is empty, then EVM will actually know that okay, this is a contract creation transaction. Okay, this data is going to be that bytecode which we just now discussed. This bytecode is actually going to be stored in this data field when we are sending the transaction. Now value is normally the price that you pay in Wei, and these three are all the cryptographic information which will verify the sender. So here you don't have any field for from address because that can actually be derived from this values. Okay, so that was one important thing to note here. Now there is one more thing to note here is that you can have same account address throughout multiple networks. Now this same account address you can have on Ethereum mainnet. This same account you can also have on Rinkeby testnet. This same account address you can also have on Polygon chain. Okay, so you can actually share the same account address across multiple networks. But one more thing to note here is that you cannot do the same thing. So the contract that you deployed on Rinkeby, you cannot use that contract address on any other chain. You have to actually deploy that contract again on Ethereum mainnet if you want to use it. Okay, so this is one more thing that confuses a lot of people. So I wanted to discuss that as well. Now, two more things that we want to discuss is first we will take a look at the ABI, how Truffle has created it under build/contracts directory. And second thing is we are also going to take a look at the account object. Okay, so let us check out the ABI. It is created in builds contracts folder by Truffle. So I'm going to click on artcollectible.json, and can you see this ABI? So this is what our ABI is, and if you take a look at here, you can find the bytecode and deployed bytecode. So this is what we'll be sending on the transaction, and let's take a look at ABI now. And here I am actually looking for claim item. So if you remember from our last video where we had discussion on our art collectible, we are actually calling this claim item to mint our NFT. So let's check this out on artcollectible.json. So I'm just going to search for it, claim item. Here it is. Yeah, so you can see this takes as an input. The name is token URI and the type is string. And yes, it takes in an input as a token URI and the type is string. And you can see it outputs a uint 256. So let's take a look at it. Yes, it gives back a uint 256, which is the new token ID. And you can also see this is a non-payable. That means it does not accept any ether. So you can see we have not defined it as a payable function. So you might be knowing that if you have went to other websites where you will be minting, you'll be paying some ether to mint those tokens, right? That is when your functions are actually payable, but in our case it's not payable. So this is our ABI. Now the next thing that I wanted to discuss was the account object. Okay, so if you take a look here, accounts have 4 fields: nonce, balance, code hash, and storage root. Okay, and this is the storage that will actually store. So if you remember that whenever we are minting the token, we are actually storing the information who the owner for those token URIs, right? So those are gets stored over here, and this is the bytecode of the smart contract, and this is the number of Wei that is owned by this address. So it can actually accept some ether, and that will be stored in this balance. And nonce is actually what we discussed, the number of transactions sent from this account. Now you might be getting getting a doubt, what about the externally owned account? Why do you need this code hash and storage root? These two fields are actually empty for externally owned accounts. These are only used in case of your contract accounts. Okay. And also let me quickly show you in the MetaMask what I have told you. So this is the same account, and you can actually use this same account across multiple networks. So if I go on Ethereum mainnet, I'll still have this same account. If I go on Rinkeby testnet, I'll still have this same account address. So you can actually share the same account address throughout multiple accounts. So yeah, so that is it folks for this video. I have tried to cover a lot of your doubts as well as how to deploy it on Polygon mainnet. So if you have liked the video, please give the video a like and subscribe, and I'll catch you in the next video. Bye bye.